Hopefully they won't all have 15 minutes of audio tests on them. Let me pull up the thing so I know what you guys are seeing. Okay, great. Let's say what we're going to be doing today is we're going to develop a mini project from scratch using AudioKit and SwiftUI, and along the way I'll try to monitor the comments and questions, but perhaps other people on the actual stream can answer people's questions, because there's most people I know, you guys could probably answer each other's questions pretty well. If something goes terribly wrong with the sound or the connection, even more than it has already, just someone on Slack let me know. And at the end I'll actually have a question answering time. So what we could do in the future would be, like, somebody wants their code to be reviewed, we could like open up a project and take a look at it together. If there's a certain problem that somebody's having, we can do that as a group. Maybe develop some examples, or highlight some of the latest stuff we've added to AudioKit, and maybe even demo some AudioKit Pro apps, who knows, or some sneak previews. So I'm going to start with a blank project. Okay, just an absolutely nothing project. And I'll do a few things here, and then we're going to get to this process. We're going to be including importing AudioKit and downloading it, everything from scratch. So there's going to be some downtime, and I've got some things to show in between those downtimes, so we don't spend all this time waiting for my computer to download stuff. So let's make an iOS app called Demo V5, and this all seems fine. Just the defaults will include tests, because hopefully we'll have time to talk about tests. Let's put it on the desktop. Okay. So the first thing you'll want to do is add a package dependency of AudioKit. Now this URL is exactly the same one as the AudioKit repo. So here's the AudioKit repo. I think you can just copy this and paste it in there. And then currently we're still putting it on a branch. I guess eventually that will just change once we have a real release, which will be very, very soon, I think. Okay, so that's the first step, is to let this download. That'll take a few seconds here at least. I thought I'd show an alternative starting point to working with AudioKit 2 instead of doing all this from scratch. So you can download the AudioKit Cookbook, which has Swift package dependencies already set up for AudioKit, and should just work out of the box. It has tons of example stuff in it as well. So if you don't know about the cookbook, definitely check it out. It's where I've moved most of the examples from AudioKit. They used to be inside the repo itself. It's now inside the cookbook, or if the project was big enough, it moved into its own repo. So we're still downloading here. Wonder if it's slower because of all the other things that are going on my computer. Okay, so then it shows you that this is the packages it wants to install, and which targets you want installed, and we just have the ones. So okay, so AudioKit is ready to go. Let's create a conductor. And just import AudioKit and then build the project. So I'm doing that now because that's the other part of this that can take some time, installing and AudioKit for the first time. So I just use V5 Develop to answer Uga Fish's question, Mark's question. I just use V5 Develop by default because that's where all the newest, coolest stuff is, and that's what I'm used to. Oh, am I not recording this even? I think it might record, yeah. Okay, so while this is building, I'll show you another place you'll want to know about. So Wiki, so all these tabs up here at the top of the repo, a lot of them people ignore because you know they're often not filled in, but the Wiki now is filled in with all the AudioKit 5 documentation. So if you want to know something about AudioKit, that's a pretty good place to look. If you have a certain class that you're struggling with, you want to learn some information about it. It's all inside the code as well. It's documented. It's documentation generating comments that creates all this, but this might be a useful resource for people. And those of you coming from AudioKit 4 will want to know the AudioKit 5 migration guide pretty well. We started with the things that are just plain old gone from AudioKit 5. Then things that you'll probably have to, if you're using these things, you probably have to make some significant changes, and then just some minor. So we basically went from the most reactive to most what I'm trying to say, most drastic stuff at the top, down to the simplest stuff. And then at the bottom is every single class in AudioKit 4 and what the appropriate version of it in AudioKit 5 is, and what's different about it. So definitely should know about this migration guide. Still building. So what else can I say about the migration guide? Yeah, I mean, we're going to touch on this, but there's a bunch of small things that AudioKit 5 do different than AudioKit 4, so it does take some time to convert it over. But most of it was done with really good intentions, that we want to build an AudioKit that is fairly safe to use. So okay, it has built. So we've now imported AudioKit, and now we can move on to actually building an app. So let's go to Conductor and create it. So these live streams, I'm not doing too much copy and paste of code. I want to make it as real as possible. It's likely my Xcode will crash along the way, or the simulator will stop working. Enough things have already gone wrong today, but this is I think this is a more honest way of dealing with this, so that everyone can see that everyone has problems with Xcode. There's not just someone who's like amazing at it, and I'm certainly not that person, if that person does exist. So the first big thing in AudioKit 5 is there's an engine that is explicit that you have to create. AudioKit 4 had an AudioKit, something called AudioKit, that was a singleton that managed a lot of things that the engine now does. This is a big update. Mainly it was done because there's a lot of unwanted side effects from that singleton, and it was really bad for AUV3. It's really good to have your own engine that you're in control over. So let's do a simple demo with an oscillator. And maybe we can put that oscillator through a reverb. So in the past, you were able to do the reverb equals reverb, but now if you do that, it'll tell us that it'll do the Xcode thing where it flashes the error and takes it away. Missing argument for parameter number 1. So because a reverb can exist without an input, we don't let you create it without an input. So you have to sometimes just define the type of variable that it is. So we have an oscillator that's instantiated and reverb that's allocated. And so reverb needs to be declared here, initialized here. And then in the past we had AudioKit.output to set the output. Now that will be your engine output. Let's make it the reverb. And then you can start AudioKit, which I think is fairly similar, but instead of starting AudioKit, you start the AudioKit engine. Yeah, by the way, it is really hard for me to look at the comments, so if someone else can answer some of these questions, it might help me out. It does a little bit more than just wrap. Audio Engine does a little more than wrapping AV Audio Engine. It does some management of connections and stuff for you. All right, so that should get us started with a signal chain, but it's not going to do anything until we do something with this. So let's write a couple of quick functions. So I'm going to toggle the oscillator. So if the oscillator is playing, stop it. Otherwise, we can play it. And then, so it's not just one frequency, we can make a function for changing the frequency. So let's just say if the oscillator's frequency is currently greater than 600, we can set it to 440 again. Otherwise, we can make it pretty basic stuff. I just want to have one of the most simple kinds of connections and conductor items as possible. So let's that will be enough to interact with. So if we go to our content view and we change it to, now I want to do a lot more with SwiftUI, and I think it's a really pretty cool technology to use for making apps. So I could do a lot more talking about like how to use SwiftUI, and I plan to, but maybe since we wasted so much time at the beginning, I'll speed through this a little bit. I'm going to be taking some shortcuts that I don't recommend. For instance, interacting with the conductor directly. Normally I would say use a data model for this, but for right now, and given how much time we have, I think I'm just going to declare the conductor as a property of this content view. All right, and we're going to have a few functions. So I'm going to just put them in a vertical stack. And so instead of hello world, we can just say toggle oscillator. And then on tap gesture, we can take our conductor and run what I call that thing, toggle oscillator. It should have just code completed. I can't do anything without code completion, but I'm going to go ahead and type it out now. And we can do update frequency from here as well. All right, so let's see. Okay, it looks like I'm missing. That might have been why I didn't do code completion. All right, so let's see if this works. It shows us interface here in Xcode. I should have done this right away, because for some reason the building of AudioKit has to be done another time for the simulator that's in here. So maybe if, you know, it probably doesn't matter if we just run it on the simulator, because I don't think it'll have to build AudioKit again in that case. Okay, so bringing the simulator back here. All right, so let's see if I got this to work the first time. Jesus, that's loud over here. Did you hear that? Might have to turn that down a bit. So toggle oscillator worked. You guys are probably glad that I didn't send the oscillator directly to your headphones. And we should go back to the conductor here and set that oscillator's amplitude to be a more reasonable number. Okay, so let's rerun that before I blow out my speakers. And so all right, so this works, and so that was I feel like that was a pretty painless, you know, process to get AudioKit running. A couple of Swift packet manage things, and then things started works. But that was just to show you how easy it is to get started. I'm going to show you now a couple of new things in AudioKit that are pretty cool. So if we go back to the conductor, the this toggle oscillator is fine. We can look at update frequency, and here's where I do have a couple of not examples, but some code I might have to paste in because it's a bit long. So one thing we can do is, instead of just setting the oscillator frequency, we can set this binding to the frequency, and we can ramp to the new value. So we can ramp down to 440 over a half a second. What's cool about this is AudioKit, actually a long time ago, AudioKit had like one ramp duration. All the parameters just ramped at that duration, and usually you set it to a small thing to avoid a small duration to avoid click sounds. Then we upped our game a bit, and then every node had its own duration, ramp duration. And now we actually can do ramp durations on the fly for any nodes. So like the amplitude here could be ramped at a different time, or this duration could be a variable that's depending on other things. So if we run this, we should hear the frequency ramp back down. It's going to jump up to 880, but it'll ramp down to 440. Okay, so that's pretty cool. That's the new ramp duration stuff. But what's even cooler is automation. So this is a linear ramping, I should say. There's no notion of nonlinear ramping. I learned from Taylor that that's a very bad thing to put in at DSP level. You want to make all these things piecewise linear. So what you do to mimic a ramp is you have a bunch of piecewise linear components. And so what this does is it'll ramp to these different values of the frequency at certain times, and it'll take a certain duration. So you can imagine how you can make any curve with small durations and a bunch of things, and you can do this procedurally too. So you don't have to, it doesn't have to be cut and paste. But you see there's errors, and this is something to get used to with AudioKit 5 as well, that we don't import everything under the sun when you import AudioKit. Sometimes you'll have to import things from core MIDI, and in this case you'll have to import something from C AudioKit. C AudioKit are the C level components to AudioKit. AudioKit is the Swift level components to AudioKit. C AudioKit, along with SoundPipe and other things, are dependencies. AudioKit has. Okay, so now it's just complaining that we haven't used it, so that's fair enough. So instead of setting the frequency like that, we are going to automate with our events. Okay. So now so it goes up. Is the sound of these automation events pretty much chosen randomly. I've done this demo with these automation events a few times, so I'm starting to get used to the howl. I kind of like it now. So that is automation in AudioKit. I'm going to quickly check the comments here to see if anything mentioned. Is that changing the underlying AU value for the frequency? Yes. So you can print the frequency at the end of here, and you will see 880. Okay, so what can we do now? Another pain point of AudioKit 4 was that things weren't. What I should do next? There's two things I could do next. I guess I'll do this one. So AudioKit 4, if you wanted dynamic connections or dynamic signal graph, you would run into a lot of troubles. And we always made we always gave the advice that if you can set up AudioKit once and then turn things on or off to emulate changing the signal graph, that would be better, because you wouldn't want to try to change it dynamically. Some people went through the trouble and figured out how to make that work even with AudioKit 4, but it's a lot easier with AudioKit 5. But it is limited to dynamic connections to mixers. So if we wanted to create another oscillator here, and just to make it a different sound, we can make the morphing oscillator. And then we can create a mixer to mix those two. Actually, yeah, we could create a mixer and mix those two, but we could also dynamically work with the mixer. So let me just set up here this oscillator 2. Let's give the index to be 3, so it's a different kind of sound. And so yeah, in the past you could do something like mixer equals mixer, OSC and OSC2, or OSC and reverb. OSC2 and reverb would be the two things we'd want to mix together. But then they're all connected all the time and stuff like that. So we don't want to do that now. Instead, we just want to say mixer and add the input for the reverb. So that's the same. This is the same signal chain as we just had. If I run this, it should just work, and it won't have anything to do with the oscillator 2 for a few reasons. One is we're not controlling it, but we created it. Really, nothing should be different. I'm just making sure that this still works. Okay. But now let's actually copy these two commands so we can control this other oscillator. I'll add 2 to the end of these. No doubt I'm going to miss one. Okay, maybe not too many to change. So now we have these functions, and if I go to the content view and I just create 2 more of these things, I'll have the controllers for this thing. Now I haven't yet. If I run this now, oops, I could put 2 there. If I run this now, these won't do anything because we won't hear anything because the oscillator 2 isn't connected. So we'll need to make one more function here let's actually swap the oscillators so I can show you both connection and disconnection. So swap oscillators. So to do this, I want to add a Boolean for is OS2 connected. So it's going to start off false. And so I'll say if OS2 is OS2 connected, then we're going to take our mixer and we're going to remove the input for OS2. And that might seem weird because we've never added it, but that's just because the logic here is making me do this first. And then we would add the input for reverb. But since it's going to start off as false, the first thing it's going to do is we're going to say we're going to remove the input for reverb and add the input for OS2. And at the end of this, we're going to toggle the value of is OS2 connected. And then in here, we can do, I'm going to just copy this real quick and put swap oscillators in here. Okay. Oops. Okay, once again, code convolution is not working. So now if I run this, I'll get a bug. I'm glad I had at least one bug today. It's a let. Okay, make this a error. Alright, so we should have different sounds now. So if I turn that on, you don't hear anything. If I turn this one on, nothing happens because it's not connected. But if I swap the oscillators, that was really loud over here. Once again, I should be setting the oscillators amplitude to something smaller. All right. All right, so that's it. That's dynamic connections in AudioKit. They, again, you can't just add or remove inputs for anything. They have to be mixers. But mixers are relatively low, CPU intensity and stuff. So they're a fine place to do that, we feel. Looking back at the comments. All right, nothing new as far as this is concerned. What I'd like to show you now is, AudioKit up, I think version 2 or something was the first version to have tests, and they're pretty cool. We would always rely on them to make sure that we're not making changes to AudioKit that change anything about the way it's producing audio. But AudioKit 5 tests are way, way better than AudioKit 4 tests were, and that's thanks to Taylor again. Taylor basically hated a lot of things about AudioKit and showed me the light on how to do things in a much better way. So he'd fix something, and then I would have to do it 100 times because his one change was like making a lot of changes. So, but it was great because now we have a lot better system to work with. And one of the things, so tests. So if I go down here to these tests and use my cheat sheet here to make sure I don't make too many mistakes. So we're going to import AudioKit into the tests, and then I think you have to do this. I'm surprised it didn't automatically put this in. So we have to make our product testable. All right, so, and it's giving this error, missing required modules, see AudioKit sound pipe. That's really a strange error to give, and it tripped me up for a while, but I'll show you how to fix it. Okay, so these little nodules here run the tests, these little nodes. So hopefully, yeah, good. No, not good. So this happened to me. So what's going on here? Tests. Tests should inherit the testability, like they should inherit the frameworks and libraries that the project uses. But for some, oh, you know what? I'm in the wrong area. Oops, sorry about that. Let's delete these UI tests. Because this is what I was supposed to be editing. So let's see if that error still came up. Yeah, so it still showed this missing required modules. Now my hope is that this fix now works, which just means run the test once. This worked. This worked earlier. I'm not sure why this is not working now. Oh, this says demo UI tests. Let's see, maybe this is going to be it. I clearly did something wrong here. Let me see. Pretty much, I think what it's doing is it's not importing anything it thinks it doesn't need to. And I am maybe stuck in the water on this. I may have to come back, or unless someone here in comments can see if they know what went wrong. Because this literally worked. Earlier today. Is it because this just exists? Oh, this is hopeful. Okay, so there you go. There's a very good example of somebody who's worked with AudioKit every day running into something that like just completely looks weird, doesn't seem to make any sense. All right, so let's see if we can make this test actually be something interesting. So you see what I did here is I created a conductor and then I created an audio stream, I guess, by starting the tests here. And it could be well, let's see, maybe if I just fill this out a little bit. Conductor.toggle oscillator. That should run it. Let's see if we get any better here. Test failed. Oh, well, duh. Okay, so all I did here was create the audio. I didn't do anything with it yet, so I actually have to render the audio for a second. So this thing just says we're going to start the testing and the total duration is going to be this, and then this is saying go ahead and toggle the oscillator and start appending audio to that stream that's rendered by the engine. So I'm hoping that this now makes a sound. required condition is false. Is PCM format. Huh. That's unfortunate. Not sure why it's stopping right there. This is really the exact same thing that I just did earlier. Well, that might be something I have to show next time, because I do not see what I did wrong. Oh shoot, yeah, sorry about that. Let me move this. I can do that. I could just turn off my camera view. Who needs to see me? In fact, that's what I'm going to do. I'll try importing AV Foundation, but it seems like it's creating an error based on yeah, it's just not getting past the creation of the conductor. Actually, I think I might know what the problem. I do know what the problem is. Okay. So, yeah, this is great. I'm enjoying not getting this right for you guys. So the problem here is that when we're initializing this, we're starting the audio engine. We actually can't do that because we're going to be doing something else. So we're going to make a function here for start engine. Now we only want to start that engine when we're in the context of this app. So we're going to do it here on appear conductor.start. That's what I call start engine. Now this is important too, by the way, for the people who's going to do AUV3, because you know, there's going to be this notion of, are you starting the engine in an app, or are you starting it inside of the plugin? So we're moving the setup of the conductor into init, but we're moving the start of the engine out. So now we go back to tests, and I'm hoping that that error goes away. Hooray, we're getting tests. We're getting audio from tests. So what's important about this is that you can now, just like we develop AudioKit to have perfectly recreated sounds when you create your nodes, you can actually make your audio engine test it this way, so that somebody comes in and makes a change, like that, you'll know about it. So with this simple test here is we can do this is not a test currently, this is just running some code, but if we think it sounds right, and we think that did sound right, we can put in this test, this assertion, that the audio has an MD5 hash that is known beforehand. So this test will fail because there's no doubt the MD5 is not going to be the empty string. But the sound is okay, so we can copy the MD5 that was generated in here, and now we could comment out the addition of the audio, and the test should just pass. Right? So, but then somebody comes along you don't know, and they want to say, oh, you know, actually we don't like the default amplitude, the default frequency here to be 440. So they just go in and they say, well, I'm going to change it to 500. Right? The app's going to compile, no problem, but the tests should fail. So let's see if they do. Sure enough. So because a change was made to the conductor that this test tested against, we now know, first of all, scold the person who did that, and secondly, if that change is something, okay, we all agree we want, just go back here and then replace the thing with this. And this is a very simple test. It's just toggling the oscillator. You can actually make it do a long set of things. So if you wanted to add another test where you swapped the oscillators and toggled oscillator 2 and then updated its frequency, like basically everything that your app can, or that your conductor can do, if you put it through its paces and rendered some more audio. Let's see what this sounds like. So to hear it, you have to audition it. All right, so that did our strange update frequency thing with the new oscillator. So we can agree that this is probably the new best MD5 to put in there. And now and you could also put these all in separate functions, so you finally pinpoint what went wrong. So instead of just like something went wrong with this whole test, you can make like, func test toggle or update frequency 2. And that would just do, that function in the swap oscillator to get it going. It would just do a small component of it, and you would be sure that, if you have 10 tests in there and only one of them goes wrong, it would kind of pinpoint into the code where you have to make your update. So that's pretty cool. I really love tests. I think they're very useful things. I think they should be in all our apps. Just because we're audio developers, we're no longer immune from tests. All right. So I'm going to take a 1-minute break here to get a drink. We're back. All right, I'm back. I'm going to check the comments real quick. Okay, either the comments are way behind where I'm at, or no comments about this stuff. It still says there's 10 people watching, so thank you for continuing to watch. Next up, we're going to add a user interface visualizations to this project. So to do that, we traditionally have used AudioKit UI, and then AudioKit UI went away for a while, and now it's back. So it is its own repo and works with AudioKit, and it's pretty simple to use. So you've already seen me install a package once before, so this is very similar. So we're going to add a package dependency for AudioKit UI. It's much faster because it's much smaller. Okay, and now our content view can make use of AudioKit UI, I hope. AudioKit UI. Let's see if that builds. No such module, AudioKit UI. Come on, just build for me. All right, so it built. So now we can add some of our AudioKit UI goodies. Like we can do a node output view of the conductor's mixer and see what that looks like. Well, that's interesting. Yeah, so this is something that came up today. I know how to fix it, but it's definitely something I'm going to have to fix better for you guys. So the issue here is AudioKit needs to be started for this node output view to work. And it is currently, let's see if I can put this around an if to see if that works. Engine this is bad, by the way. I don't think this is the way it should be done in the end, but I want to see if this at least allows us to fix this. If this doesn't work, okay, so that still doesn't work. So what I'm going to do is I'm going to go back on something that I told you guys to do for now, just to show you these views. So AudioKit needs to be started, or the engine needs to be started for this node output to work. I think that's what the problem is. Actually, now that I think about it, this might not be the problem. Let's find out. See if that helps us out at all. I thought I fixed this afternoon with Matt Pfeiffer. Well, maybe we just fixed it for the FFT view and not for this. Huh. Or this could be something else altogether. So let me back up here. Bring that back. And put that back where it was. And try to see if it's this problem here. FFT view of, see if that works. That was working earlier. So, but so was the output view for that matter. Okay, this is already looking scary because it's taking its time. Yeah, something says deadlocked. I'm actually going to try quitting this simulator and starting from scratch. Okay, that worked. Starting the simulator was the problem. You know, that I always tend to blame myself and not Apple, but I really should get in the habit of blaming them. All right, so let's go back to where I was going to show you this node output view. Yeah, that's some good suggestions in the comments, but as you can see, it was just the restarting the simulator. All right, so that is a metal-based view. It looks a little bit weird that it's when it's big like this, but it's going to get squished down as we add more views anyway. Yeah, so there's a couple different ways we could solve that. One would be just to give that view a frame height, like 200 or something like that. Cool, so that is actually metal-based plot. We're getting rid of the easy audio-based plots, doing everything ourselves. We'll still probably have some core graphics generated plots, but this is really keeps the rendering on the GPU. Should help for the audio stuff that's happening on the CPU. Okay, I'm going to answer some questions in 1 second, because this is the last thing I want to show you, and I see some really good questions on there. So this is newly created by Matt Pfeiffer FFT view, and it's beautiful. And it doesn't work. So who can tell me? I probably can't do this because the delay is so long. But who can tell me what I've done wrong? I'm just going to tell you. The problem is these things all run off taps, and you can only tap one thing at a time. So we can either create, let's just do the right thing and say, we create a secondary mixer. And then we can just say mixer 2. Oh, sorry, it's not mixer 2. Mixer 2 is add input mixer and make the output mixer 2. Yeah, Matt Pfeiffer gets it right. So now we go back to the content view, and we're going to plot the mixer 2 on here. All right, so now who can tell me what's going on with this FFT view at the bottom of the screen? I think only Matt should know what's going on with this. So I think what's happening here, I just saw this for the first time today. I think what's happening is the reverb tail is very, very quiet, but it's still representative of what was going through it, because if I toggle it there, you see that the frequency that it was at is still up there. And if I toggle it again, turn it off, it's still there. So I think what's happening is the reverb is still decaying, but it's so quiet, and this is all being normalized, so it's getting quieter and quieter, but we can't hear it, but it's there. And the very last second, it all goes to zeros, because just in a crazy way. I think there should be something in the FFT view that will make it not normalized, or to avoid that sort of thing. But this is a brand new feature, that FFT view. It's super cool looking, so everyone give a shout out to Matt Pfeiffer for adding that to AudioKit UI. That's right, Marcus. Marcus got that right about normalization. There's one last cool thing I want to show you guys. This is the coolest thing about Swift Package Manager basically in the world. If you've got these Swift package dependencies, but you are developing AudioKit or developing AudioKit UI, and maybe other people in your group are they don't want to have to deal with it, just want to use Swift package, but you want to make changes to AudioKit or AudioKit UI. All you do is you drag in your local copy of AudioKit into your project. Xcode is smart enough to know that you've dragged in AudioKit, and it removes the Swift package dependency, and now you can make changes to the AudioKit stuff inside your project and then make pull requests, hopefully, with the changes that you've made. And then once it exists on a branch, you can tell your coworkers to point to their, or you can actually then, once you're done, let's say you're done, you think AudioKit is all fixed up, you can remove it from here, just drag it out. I don't want to drag it anywhere in particular. See, let's just say remove, delete, and then remove the reference. What it'll do is it'll go and grab the latest AudioKit. So you might have to say at this point, let's say the pull request was accepted, you might have to say here, update to latest package versions to make sure you're pointing to the newest version of AudioKit. But it is fetching the new copy, so if you did do that after it was already accepted into AudioKit, I think it might get the right one. I'm not sure. It might also just grab the one that it knows it needs to grab. But that works with both AudioKit and AudioKit UI, so it's really good for us developers of AudioKit. And really, we should all feel like developers of AudioKit because it's a framework for everyone to use. Just remember, when you make your pull requests, write tests for the things that you change. Try not to be too hokey with the variable names, or give it a shot. We're pretty nice about giving code review when we get pull requests. Maybe I should let other people speak for me on that, but I think I'm pretty nice during code reviews. All right, so someone asked a question that I do want to answer because it's actually something I was going to bring up. Let me find it. So Bark said, in Cookbook, you don't use a conductor class. Is there time when you recommend it over not in conductor, and why? And our audience said, I think I saw a conductor inside the recipes, and that's right. There are conductors inside the Cookbook, for sure. Each file here has its own conductor so there's a chorus content view, basically, a chorus view, and there's a conductor, all done in one file because I wanted to keep it like a recipe, everything in one place. But the thing that I did not do today, that I think is a smart thing to do, is to make a struct for the data that is defining your app. So the data model for your app is defined somewhere else. And then what you do is you have your conductor respond to changes in the data model the same way your content view responds to changes in your data model. So Swift UI sees that where's the data model defined here? Has the conductor. Oh, actually, it's done a little bit weird in the recipes. Maybe I'll change this eventually, but the data is defined here, and whenever it gets changed, the conductor updates its information, and then the conductor is changed, so the observable object, the chorus, it changes. Another way to do that would be just to have both. The data model sits completely alone. The content view changes to it, and then you make the conductor subscribe to those changes. And I think I'd like to do that. I just don't know that we have time to really do that today. It's pretty simple. I could sort of, I mean, what would I have to do? I can see how far I can get in a minute here or something. But so if we had like a struct for a data model, and inside of it we would have like is oscillator 1 playing? Starts off with false, right? That would be your observable object. And inside here, you would have your model equals the data model, something like that. And then you could make it so that the oscillator's toggability would be based on the data model. And then inside the conductor, you might give the conductor the data model and subscribe to the changes. You know what? I think I will wait for next time, and maybe I'll make a really quick, clean example of doing that. Just because I can already see it's getting late and I'm getting a little scattered, so I don't want to go onto that road. But definitely do what you can to keep. Like my advice would be try to keep AudioKit in one set of files. Like you shouldn't be importing AudioKit everywhere like we used to do. Like if you look at Synth1's open source, AudioKit is imported in every single file. It really should just be the audio stuff that uses AudioKit. The Swift UI stuff can use AudioKit UI, but try to make things as modular as possible. It's the new way with Swift UI, and I think it's just a better way of treating yourself to writing good code. Oh, Taylor's pretty late. Don't worry, I did all the bad mouthing of you early on, so it's all good. I think this is all recorded anyway. There was 20 minutes of not being able to get the audio to work, so you're probably good to be late. So unless I get any more questions, I think we're mostly done. Yeah, for sure. Having a data model in AUV3 is pretty straightforward. So you would want to create your data model inside of the audio unit controller, and then and then make sure the data model inside the conductor is equivalent to that one. So I can probably share some code with you. Basically, you want to have the app version of your app use the data model that's created in the app at the app level, and then you want the audio unit controller to have its own data model that it sends into the conductor. Yeah, I'll definitely figure out the audio. Yeah, I'll try to do this every week at this time. Maybe I'll also change the time for people who are overseas. We are an international community of people working on audio apps, so there's some people that I'm sure Friday at 7 is not a good time. It's a new year. Just want to say thanks to everybody to come out. AudioKit is where I've met in the last 10 years my best friends of all time, practically, and glad I started it for that reason. And I'm sure, as I do these live streams, maybe I'll get a chance to meet more people. I'd love to also figure out how to do live streams with two people talking, so that we could do some like either interviews or joint code sessions, so it's not just me talking to screen every once in a while looking over here to see what comments came in. Cool. Well, also, we have a Slack group, so it's another good way of getting in touch with me. Just hit me up. If you're smart enough to figure out what one of my 100 of email addresses are, you're smart enough to get on our Slack group. So email me your email address, and I can add you. Yeah. So Happy New Year, and I'm going to end the stream now. If I can figure out how.